Okay, here I'm going to demonstrate the operation of the menu. First turn it on, it'll initialize. Come up to this little splash screen, press any key to continue, and you get your default duration at 15% and delay is at 17.5. It's automatically in the automatic delay mode, comes up by default. So you see your RPM up there, and I can demonstrate how the RPM changes on the screen by adjusting the function generator. Take it up to about a 200 hertz signal. Trying to tune that in now. There we go, about 200 hertz, a little over 200 hertz. So the tachometer feature works pretty well. It only updates every 3 seconds, so it doesn't burden the processor too much. So if I want to change the duration, I press number 1, takes you to the duration screen, and the keys are numbered next to each one of the different percentages. You can take it up 0.1%, 1%, 10%, up or down. So it displays it on the screen up there. If I say increase it by 10%, you see our delay is down to 2.5% because the automatic delay kicked in. So I'm going to go ahead and take that down, and now it's at 7.5%, the automatic delay. Now it's at 17.5% again. Take it down to 5% and go back. And you can go to your delay menu, and you can adjust your delay manually, or first you'd have to turn off your automatic delay, and then you have the same features changing the delay. I can go down 10%, down 1%, down 0.1%, and the same for go up 10%, 1%, and 0.1%. So hopefully that's clear enough on the screen. Maybe that's a little bit clearer. I'll turn auto delay on with number 7. I'll go back, and we see that the automatic delay kicked it into 22.5% on its own there after turning that back on. So duration, up, 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 down 10%, down 1%, down 0.1%, back to the main menu, and of course I have the start. If I hit start, okay, notice on the scope the blue trace is at the bottom. It's dead. I'm going to hit the start, number 3, and there we go. There's our 5% signal with 22.5% delay. That's about it. Okay, here's a demo of the jitter of the output signal from the Arduino. You see that it's set at 50 microseconds per division, so that jitter's probably about 40 microseconds. And experience that at all speeds. That is all input frequencies that I've measured. Right now we're only at 627 hertz. Sorry for that bad shot there, but I'm not going to take the time to focus that in. So that's what I wanted to demonstrate here. Okay, here I have a 812 hertz signal going into the system. It really shouldn't matter what the frequency is going in. The point here is the processing delay. We're set up at 50 microseconds per division here, and there's 3, and well, we'll just call it 150 microsecond processing delay. Now the yellow trace is the input signal and the blue trace is the output signal, and they are inverted because the place I'm looking at the gate of the power MOSFET, so they're inverted. The yellow trace is simulating the Hall input signal to the processor. So 150 microsecond delay processing, and that includes the opto-isolators in and out of the circuit, and that this really doesn't take into account the switching of the power MOSFET, but that's going to be negligible. So there's the biggest delay, is the processing. That's it for this. Alright, this is a combo demo. I'm going to demonstrate the auto delay correction function, the software, and I'm going to demonstrate the pulse duration, how I can change that, and also the delay manually. So right now I'm set at 2% delay. The scope is set up at 5 microseconds, 10 volts per division, and the yellow trace is the input signal and the blue trace is the output signal. And the output, as I said, was at 2% pulse duration. I'm going to go ahead and increase that, and with the auto correction on, notice how the signal stays pretty much centered between the pulses. Again, the signal is inverted, so this is the correct output I want. I'm just incrementing it 1% at a time. I'm at 31, 32, 33, actually 39, 40. So I'll take it up to 50% pulse duration. Okay, so there we are, and it stays centered pretty well. It's with the auto delay on. Now I can go ahead and turn that off, and the auto delay is set at 0% now. I'm going to manually change the delay, so I'll turn the auto delay off, and it stays centered because it keeps the same percentage that the auto had. Now I can adjust it up or down. I'm going to adjust it up 10%. So I'm at 30% now. You can do that singly or 0.1. You can't really discern the 0.1%, so I'm at 36.6. I can go ahead and decrease that one at a time. I'm at 20% right now. I'm going to take it down to 10% with a touch of one button. Okay, there's 10%, and I can further decrease that until I'm down to 0. So that's a pretty nice feature to be able to correct that manually or have the auto delay on, because that feature works pretty well. It's unproven though at high speeds, I must say. I've taken it up to 25,000 RPM with that, and it worked like a charm. So I'll take that back. Okay, so I'm at 4,600 RPM right now, but it works pretty well up to, like I said, 25,000 RPM, which is equivalent to 416 hertz input signal. So that's a pretty nice feature to have, the auto delay. This is a demo of the motor running. The blue trace is at the bottom of the coil where it connects to the power MOSFET, and the yellow trace is the Hall sensor output. You notice that the coil is being fired right in the middle of the downside of the Hall. And I can demonstrate increasing the duration. I'm not going to do it too much because it'll get too loud. Hopefully this comes through clear as it is. So I'm going to increase it 1% at a time. And you should notice you can increase it to 10%, a 10% jump now, and you'll notice that. There we go. I'm going to take it back down. You notice how it stays in the center there because of the automatic delay. If I had that turned off, it'd be jumping around. So the automatic delay adjusted itself to 19.5% right now. I'm going to turn the duration up a little bit. We're at 2800 RPM right now. The scope's set at 1 millisecond per division, and they're both, well, channel 1's set at 1 volt, that's times 1, and then channel 2's times 10 at 1 volt, and that inductive collapse is that spike right there. You see it goes off the chart. I'm getting over 1,000 volts, around 1,200 volts across the recovery capacitors I have set up. Let's see if I can get that on screen. There they are. Those three right there. They're rated at 500, so I'm pushing them about 400 volts a piece, over 400 volts a piece. So yeah, this thing puts out quite a spike when that magnetic field collapses. There you have it. One last thing about the software. When you press start, the number 3 changes to stop. So let's stop it. I'm going to power down now. Thanks for watching.